You might have used some of Excel's built-in functions for calculating probabilities or percentiles for theoretical distributions. For example, the normDist function finds left-hand tail probabilities for a normal distribution, and the norminv function looks up percentiles for a normal distribution. Here are a couple of examples. At-risk provides similar risk-Theo functions, where Theo is short for theoretical. These functions are described in this video. Recall that when you open a distribution from at-risk's Define Distributions window, you see a graph such as the one you see here. It includes a variety of summary measures in the right pane. These summary measures are the values calculated by the risk-Theo functions. You can find a list of all risk-Theo functions in the theoretical group under the Insert Function dropdown on the at-risk ribbon. For backward compatibility with previous versions of at-risk, several of these are equivalent. Specifically, risk-Theo P to X and risk-Theo Q to X are equivalent to risk-Theo percentile. Each finds the percentile of the distribution for a specified percentage. Also, risk-Theo percentile D, D for descending, is essentially equivalent. If its percentage argument is, say, 0.05, it returns the 95th percentile. Similarly, risk-Theo X to P and risk-Theo X to Q are equivalent to risk-Theo target. Each finds the probability to the left of a given value. Risk-Theo target D finds the probability to the right of a given value. The worksheet you see here illustrates several examples of risk-Theo functions. Each of the cells in green font in row 2 contains an at-risk distribution function with the parameters shown below it. Then various risk-Theo functions are used in rows 9 to 16 to calculate various summary measures of these distributions. Risk-Theo mean, standard deviation, minimum, maximum, 5th percentile, 95th percentile, which I've done with the D version using the 0.05 argument, the probability of being at least 2 standard deviations below the mean, Theo target, and the probability of being at least 2 standard deviations above the mean. Here I've used the D version for the right-hand tail. Several of these return value errors. This is because the minimum or maximum of some of these distributions is unbounded. There are 2 things to note about risk-Theo functions. First, they are not based on simulations. Simulation, after all, is all about estimating distributions of outputs that are functions of input distributions, often very complicated functions. In contrast, risk-Theo functions operate only on the gallery of at-risk input distributions. In fact, risk-Theo functions are essentially hardwired to these input distributions. So they return exact values, not estimates from a simulation. Second, the only arguments risk-Theo functions accept are at-risk distribution functions. Again, this is because of the way they are hardwired to these distributions. To convince yourself of this, enter the formula equal 2 times B2 in cell B3. Now try taking risk-Theo mean of this. It doesn't work. You get an error. Actually, if this did work, you would have a gold mine. You would be able to find means of functions of input distributions without any simulation. so you wouldn't need simulation at all. Again, risk-Theo functions have essentially the same value as Excel's statistical functions like norm_dist and norm_inv. They allow you to calculate summary measures of many commonly used theoretical distributions. The advantage of risk-Theo functions over Excel functions are that they have more functionality and they apply to more distributions. For example, Excel 2010 has a Weibull.dist function for calculating probabilities of a Weibull distribution, but it doesn't have a function for calculating the mean, standard deviation, or percentiles of a Weibull distribution. Also, it doesn't have any functions at all for many of the lesser-known distributions in at-risk gallery, such as logistic, Pareto, PERT, and others.